Hello and welcome back, hopefully back. Nice to see you. And today I want to speak a little bit about batched inserts. We'll talk about Spring Data, Hibernate, JDBC, Postgre. And what is the problem now? Perhaps you know that when we work with secure databases, we can insert our data in two different ways. We can insert a single row with a single insert statement, and we can insert several rows with a single insert statement. So we can batch a couple of inserts together. But this has some quirks, and in the context of a sample project, we'll look at them. So sit back, enjoy, and I hope you will find this video useful. And welcome to our very simple project, which is named Batched Inserts. We'll make some experiments here. There is nothing special about the project. It's a very simple Spring Boot application, which uses Spring Data and has Hibernate under the hood. I use also Liquibase to create my entities here for some additional flexibility. What else? Project is connected to my local Postgre database, and this database I have, with some tricks, I have set it up to print the SQL logs so that we can monitor these logs live while we make some experiments. We can, of course, rely on the logging of Hibernate, but you will see that what prints Hibernate is not always the thing that is getting executed in the database itself. So here is a look on our entities, the entities that we are going to experiment with. These are the classic post command entity. So we have one single post which has an ID and a small space for the post itself, and this post has many commands. Nothing special here indeed. Let's have a look at the entities. Also nothing special here. Maybe it's worth to mention that the strategy for the generation of the ID is identity. This means that we'll rely on our database to insert values for the IDs. This happens under the hood with the sequences, which are automatically generated for us. And I can even show you the video, nothing special here. So we have our column begin generated by default as identity, and the sequence which is responsible for this ID is the post ID sequence. We can see similar thing in the command entity. Currently, I have commanded out the other generation strategy, and I'm using here also identity. How do we create a post, a sample post? I'm using the post service, calling do insert, and here you can see 1, 2, 3, 7 commands, one post, and this is saved in the database. We will see queries that are executed. So currently the project is running, and I'm going to clear the console. Actually, it's cleared already. And here I have created a small endpoint, which will trigger the creation of the post and 7 commands. So I run the rest, and you can see here that we already have our inserts. They come one by one, so we have one insert for every command. Now our task is to try to change that. We want to have a single insert for multiple commands. To do so, now we have to visit our application YAML now, and there are some properties which we have to configure for the Hibernate in order for this to work. Hibernate has a couple of properties which we can use and should use actually, and these are the order inserts, the order updates, if you want to do the same thing for the update queries, and the batching size. So how much generic, what is the size of our batch that will go to the database. Why do we need this ordered insert and ordered updates? That is because the SQL queries should be ordered in order to be batched. So, for example, we shouldn't get an insert, after that update, after that another insert, after that delete, because this will be incredibly difficult to batch. Further on, you have to know that Hibernate does not implement batching itself. It relies on the JDBC API, which supports instructions for batching. And in order to enable this, we should change our URL. And here you can see one parameter, which is rewrite batched inserts. Okay, at least at the beginning, it should look like we'll be able to batch our inserts. But what happens here if I open my REST API, and I will also open the database, can I clean this more intelligently? Yes, I can. And if I run my experiment once again, you will see that again my comments are not batched. So I'm getting first insert into the post table, and then here we have 7 more inserts. Why is this? That is because currently we have this generation strategy, which is identity, and Hibernate will not be able to use batching if we rely on the database for creating automatically our primary key. You can see here that we don't insert the ID. So we just insert the command and the post ID, and we expect that our database will create the key for us. This cannot work with batching, and Hibernate will not be able to cope. In order to make the things work a little bit better, I will uncomment this generator here. We use the strategy type sequence, and we have to link to a sequence generator. And I will use this very same sequence, command ID sequence, which is created for us automatically. And maybe I will start with initial value 1 and allocation size 100. What does it mean? It means that Hibernate will call this sequence once and will reserve 100 IDs for later usage. So this means that, for example, we call this sequence once, the sequence advances with 100, and Hibernate will be able to insert 100 elements without invoking the sequence once again. Let's see if this works. This will work, but with some unexpected results, and we'll see them in a minute. I will drop all the tables here. I will stop the application, and now when I run this application once again, I will try to do our insert. So let's have a look here. I started the endpoint. I call the endpoint, and let's open the comments section. The first strange thing that we see is that we have a very interesting IDs. They're negative for some reason. And maybe it's worth to mention something else. Let me see. We have here many SQLs flying. Okay, I cannot find easily. That is why I will call the endpoint once again. Calling the endpoint, and you can see here that another strange thing happens. First, we have some batching here. The first batch of insert statements, it's up here, contains 4 commands. The second batch contains 2 commands, and the third batch contains just 1 command. And again, we have here negative values. We have to understand why the values are negative and why we have such strange batching. It's really strange, and currently I cannot really explain myself why they did that, but we'll have a look at the JDBC driver itself and why it works like that. Now let's tackle the negative IDs. The negative IDs are negative because by default this sequence, which is this automatically created sequence, command ID sequence, it increases by just one every time in which it is called. And the thing that we have to have in mind is that if we have a location size here, our sequence should also increase with the same pace as our allocation size, which is created here. Otherwise, Hibernate thinks that it has 100 IDs at its disposal. For example, we create the first step. We start with initial value 1, and Hibernate decides that it has 100 IDs allocated for itself, and start subtracting 100 from 1. And that's why we have negative IDs. If we want to fix that, we need to simply create this sequence by hand, and I will do this right now. So here in the commands, I have prepared my command ID sequence, which will be incremented by 100, by step 100 every time. And what else? In the command table, I will remove this auto increment equals true, so that Liquibase is not tempted to create this sequence automatically for me, and we'll see what happens. So I will delete all these tables, and we'll have a look how they are created once again. Great. I clear my output, and here I do some refresh, and the sequence is already here. You can see the DDL. It is incremented by 100. Now I will run the API once again, and we'll see what we have in the console. So the commands are created. You can see here that every command is inserted with a separate insert statement. At least the IDs of the commands are now perfectly fine from 1 to 7. And what we see in the database, on the side of the database, is again this very strange thing. We have first a batch of 4 commands, then a batch of 2, and finally a batch of 1. Maybe it's worth to mention that we have here an ID, which is generated by us by the sequence generator, which we have configured with an annotation. So we handled the negative IDs. Now we have to explain these strange things with the batches. First, why doesn't Hibernate print the SQL statements here in batches? As I have said, Hibernate doesn't do the batching by itself. The batching is done with the help of the JDBC driver, which has a special property rewrite batched inserts. So Hibernate sends to the JDBC driver these queries, and the JDBC driver automates them under the hood. That's why you see here one thing, and in the database the actual situation is quite different. We have to remember that not everything that Hibernate outputs is the same as the things that go to the database. In order to explain this very strange batching size with Postgre, with other databases, things might be quite different. We have to pick at the source code of the JDBC driver itself, because it does the batching itself. So this is the source code. It's available in GitHub, so you can have also have a look at it. And the thing that we're interested is deep down into the JDBC jungle, and the class is named PG prepared statement. So some guys decided that typically it doesn't make much sense to batch more than 128 rows. Exactly how much rows shall we batch depends on many things. For example, how many bindings we have, how many values we are inserting, and so on. But the maximum, the highest block count, the highest amount of inserts which we batch should be no more than 128. In our case, with the comments, we have 128. The max value of blocks is 128 because we don't have too much. Bindings into our insert statements. So we'll never enter this code here. We'll enter instead this very interesting piece of code, which decides how many of our inserts will be batched. They use this highest 1-bit method of the integer, and initially we have unprocessed batch count, which is equal to 7. Let's do some binary mathematics and see how much is 7 in binary. So I will use this file for doing the binary maths, and 7 is written in binary like this. So we have 7. And what happens with the method itself? It will return the highest 1 bit. In other words, it will return like this. And this number is 2 to power 2, which is 4. So this is 4. Just one second. Is 4. And this is 7. So the first batch will be just with length 4. And we can see here, somewhere here, 1, 2, 3, 4. That's really very interesting. The second batch, so we have 3 more left because we have inserted so far 4 commands. And we have 3 more left. 3 is written in binary in this way. This is the number 3. And if we have the number 3, this function, the highest 1 bit, will return 1, 0. So we have here 2 more records which will be inserted. So you can see that the second batch contains 2 rows. This is really interesting, and I don't have an explanation. And the remaining is 1. So let's think a little bit and see what will happen if we, instead of 7, we have 8 commands. Let's make some experiments. Where is my post controller? Yes, the service. And here I will make another command number 8. And here we will insert another command number 8. I'm going to clean up everything, and we have to restart the application. And I will also clean the logs so that we can monitor them. But before that, let's think and try to deduce by ourselves what will be printed. So we have 8, which is an even number, and it's written like this in binary. So the function, which is highest 1 bit, will return the same number 8. So my expectation is that if we have 8 commands, all of them will be inserted into single batch. Let's see if I'm correct in my assumption. So you can see here we have just one insert statement with 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. We have no more inserts, which is very interesting. Let's continue the experiment and create one more example. In this example, we will insert 9 commands and we'll see what happens. Or even 10, maybe we can do 11 so that it's more interesting. So Just a second. 9, 10, 11. It's really insane. No idea why they did it like that. Perhaps they wanted somehow to insert just even number of in a single batch, which is not something not easy to be, something not explainable easily. And let's think what will happen. In my opinion, what will happen, this is the number 11. So the first batch will be 8 pieces because has 1 bit returns 8 pieces. And after we have 8 pieces, 3 more will remain because 8 plus 3 equals 11. And 3 is written like this. When we apply this function, this will make 2. And finally, we have just a single one, which is remaining, so that it will be inserted. So, in my opinion, 3 insert statements. The first will be batched 8 blocks, then 2 blocks, and finally just a single block. Let's have a look and see if I'm correct. We'll start the application. I will clean up here the log and let's run the API and see what happens here. Yes, we have 1, 2, 3, 4, 5, 6, 7, 8 in the first insert with this quite amazing algorithm. Then we have 2 inserts in the next batch, and finally we have just a single insert. No idea why they did that, but just it was just very curious, and that's why I decided to share this with you. I hope that I made some of the concepts a little bit more clear, and I wish you happy batching. If you want to support me, you can do this in the usual way for YouTube, and I hope to see you again. Bye bye.